Hello folks, this is tutorial number 14, which deals with my fourth strategy to solve a problem that started being defined in tutorial 10. Here I will use the coupling option in the connections of the 3D Experiences FEA module, and for the other connection I use actually connector, which is the hinge. Okay, so let me remind you what the problem was that we discussed in the previous 4 or 5 videos. We have a beam structure like that, and left end is clamped, right end is on a roller, and there is a internal hinge at the point B, which means there's no moment there. Now there is a concentrated force at the middle of AB, and I did this problem many different ways. The very first one was called obvious strategy, and all I did was to create a line AB and a BC, and then place the load in the middle of the mesh for line AB, and that's why I called it obvious strategy. But then gradually we made this thing more complicated, and this is why I call it killing a fly with a cannon. So I did several different things, create a welded connection between these two and a hinge between these two. And then I did a tie connection between these two and hinge connection over there. And then I also did, I think, a rigid connection between these two and a hinge connection there. Okay, so what I want to do today is use a different feature, which is called coupling connection, and of course the hinge there. Okay. Now, this is from Hebler's structure analysis textbook, and with this information, the deflection at the point B should be 4.58 inches, roughly 4.58 inches. And the derivation of where this number is coming from is in the last last 3 slides, where I used the principle of visual work to calculate the deflection at the point B. Now, my strategy goes like this then. So I create 3 wireframe lines in space, and the concentrated force goes here and the hinge goes there. So I create a connection. It's called couple, actually. I use something called couple in the connections icon between the end of the end of this line and the end of that line. That's going to be couple, okay? And because this is deforming, there's no hinge here, this is deforming as if it was just smoothly deforming as a beam, couple. And then over here, I'm going to use a hinge connection. In tutorial 10, I showed that it doesn't matter whether I use a hinge or a joint or a cylindrical connector, they all give you the same answers. So don't join anything because you want to have duplicate nodes here, okay? And make sure that when you mesh these beams or lines separately, this box is off, because with this box being on and the tolerance specified in the rest of this capture feature here, functionality, these are going to be merged. I don't want them to be merged. I want duplicate nodes, and therefore this is going to be off. Okay. Now I will not do join and cylindrical. That was done in tutorial 10. All 3 of these were made and showed you that you get the same result, but here I only use hinge. Now remember that for a hinge, you need an axis system, local coordinate system. The origin of this doesn't matter, but the direction of it determines the direction of the hinge, as shown here. This direction is the direction of the hinge, direction 1, which is my x. Then here is the principle of visual work to get the deflection of the point B, and you get 4.58 inches roughly. So let's go ahead and do that. We go to 3DEXPERIENCE and start with the part file, because we're not going to be joining anything. I don't need join, so I might as well do it there. And create a wireframe here, essential line. For the line, I do point and direction. There's the point 0, 0, 0. Direction is Y. Direction Y. Hang in there. Oh, I'm sorry. Point and direction. That's what I wanted. Yeah. Direction Y. And length 12 feet. And then repeat it again for the second piece. namely, uh, yeah, the middle line. So another point and direction. Here's the point. Direction is Y and 12 feet. Another one. Point is here. Direction is Y and it's 15 feet though. Okay, so I've got all three of them. Now let me create my coordinate system. Here's the axis system. And the drawing shows that I do it here, but just to remind you that it really doesn't matter. What I'm going to do is I'm going to create the different location. For example, let's make it 5 feet. Actually, let me make it 10 feet so that we can see it better. And even Y, I can make it 10. That's some other location. But the direction of the hinge must be now, but instead of drawing it there at that origin. Okay. So let's apply material to this. Go to tools. So steel tutorial 14. All right, it's going to be created here. I'm going to put this thing on that part, green check mark, and now we're going to input the values. So let me go there. Under structural, abacus multiphysics, mechanical, elasticity, elastic, 29,000 KSI, 29000 KSI. Poisson ratio 0.3. It doesn't matter, I can leave it as 0.2 because you're not using it. All right, now this is done, so we're going to do the meshing. So let's yeah, we go to the structure model creation. I'll say yes, it's an empty FEM. Here's the beam beam measure. You select this, 1 foot long, so there's going to be 12 elements in this direction. Notice that this checkbox is off. And do the other one, this one. Again, 1 foot, okay. And then another one over here, and that's going to be 15 elements, right? Mesh, 15 elements. So I should have my elements right there, all three of them. And now we do the cross-sectional properties. So properties, let's create a profile here. Beam profile, circular, 2.486 inches. Don't forget IN. Good. And then beam section, this and that and that. And profile number 1. Incidentally, if you want to be able to see the cross section of this, what you can do is you go to display, display option, say that show me with a solid. Right there, you can see that shown to you as a solid. Okay, but if you don't care, you don't want it, just put it back on none. Okay, so we created our mesh, and we have to do the property. We did the properties, very good. We're done here. So, connections right there. Now, let me remind you that here we wanted to do a hinge, right? So let's go to the connections tab. Let's go to the connector. I'm going to change that thing to hinge. I'm going to select the support one. So one of them is going to be the end of this line, the right line, and the end of middle line. Okay, so just make sure that we don't pick the wrong stuff. So let me hide the middle one. So for support 1, I select the end of this, and for support 2, I select the end of the other line that I put in hiding, right there. There. All right. Now also notice that it's asking, it's expecting you to select the axis system. So the cursor there, and there's the axis system that I use. So axis direction of the hinge, and it should be okay. Now this line isn't hiding. If you want, I can bring it up, but I'm going to leave it the way it is. Now, here I want to do a coupling. So remember, second one is a coupling there. Okay, so let's go ahead and find a coupling. There's this coupling. Again, support one, I select the end of this. For support two, I select the end of that line. And it's point to point. I don't want to use a spring. They're going to be coupled together. They move together. So now I can bring this in the front if I want to see it, the whole thing. Good. So there is the coupling. There is the hinge. Uh, Now we're going to go to the structural mod scenario creation. Choose our finite element model. Okay. And for procedures, select the static perturbation. For the boundary conditions, I select this endpoint. Let me see, boundary condition clamp. I select this one. Notice that I can't pick it because it's in hiding. Let me bring it here. Let me bring this in the show mode. Now do clamp. Now I can select it right there. This one is on a roller, so we go to fixed displacements. So this endpoint cannot move in the direction X or Z, but it can rotate about X and cannot move in Y and Z. So that's good. All right, let's apply our loads. So we go to loads, force. At this coupling point, at this point where we actually did the coupling, minus 8K. Oops. Let's try again. Minus 8K. Okay. Yep. Oh, I see. Minus 8. Sorry. Minus 8. Good. All right. And then we have a concentrated moment at this location. That's a torque. We select this point. Oh, not that. Yeah. Zoom in. Let me hide this. There. And about the x-axis, it's going to be minus 30,000. Minus 30,000, 30,000 pound foot. Good. Okay, so something is hiding here. Let's get it back. Boundary conditions. This is hiding right. If you want to see it, you don't have to bring it back, but right there. Now, that's pretty much it. So let's actually go ahead and check our simulation. Check. Yeah, that's good. And then I'm going to simulation check. Do a simulation check. So I have a better peace of mind. This is going to be quick. Close that. And then we're going to simulate. Why should be getting 4.58 downward? One thing that bothers me is that the coupling did not have a symbol at that location. I was surprised actually. But let's move on. Is it 4.58? Let's find out. Displacement, yes, 4.58. You can see that.